Okay, ladies and gentlemen, here we have a unique version of Jenga. This is Jenga Octagon. What makes it unique is it's eight-sided, so as a result, the pieces will come out at weird angles. Rather than just being like this and like this, we've got some at 45-degree angles. So instead of having forces acting forward and backwards and left and right, we also have them moving in other directions. So right now, Newton's first law of motion is in action. It takes Newton's first law, object at rest, remain at rest until they're acted upon by the outside force of my finger. There's some other unique aspects of how these get played. So you can play these sideways to make it more challenging as we go along. My wife is about to demonstrate as her turn comes up Newton's second law. It takes a force to accelerate a mass, so she's going to use the force of her muscular force, her fingers, to move a piece. Notice as these pieces are moved as well. We're going to ignore the fact that she's cheating by using two hands. You'll notice Newton's third law of motion. For every force, there's an equal and opposite force. That's 3 on this row, so that's all we actually need. So I start to pull on it. The friction starts to tip it one way, and its inertia pulls against me. So we've got these equal and opposites causing the whole thing to sway as we're playing. So you can play that flat or sideways. Flat it is. We're waiting for the moment for Newton's first law, that second half, objects in motion stay in motion, to occur. Basically, the whole thing's going to start to fall, and it's just going to keep falling until it meets the resistance of the table, which is the outside unbalanced normal force acting on it. Pop that one back in. Oh, no, I'm going to play it like that. I showed her that move. Oh, there it is.
If you breathe too hard, it's going to fall over.
I know. We want to see Newton's first law in action. Everybody's rooting for you to knock it over today, Lady Pam.
When you say everyone, you mean you?
Me, yes. Everyone named me. Yeah.
Because that's
You notice how it's swaying already? This is Newton's first law really in action here. Because instead of just being at the 290 degrees, it is these 45 cause some different unbalanced forces to be present than in a normal Jenga. And the frictions definitely affect how they act. We're waiting for an unbalanced force to cause the whole thing to come tumbling down, because right now they're objects at rest. We'll see if that lasts any longer here.
Oh no, that would definitely make it fall.
I'm okay with that.
Okay.
Unbalanced force of gravity. Unbalanced force of gravity. Objects in motion. In motion until normal force of the table stopped them. Make sure you diagram it.